Here's another example of a quadratic equation, and I want to solve this equation as I did the previous one by using the quadratic formula. The quadratic formula always works for finding the solution to a quadratic equation. First, put your equation in standard form, which this equation is in standard form. Remember, highest power term, then the next lower term, then the constant equals 0. You always want it equal to 0 when you use the quadratic formula. Then I need to identify my A, B, and C coefficients. Well, here A is 6, B is negative 13, C is negative 15. So we're going to take these values, plug them into that expression in order to find the solutions for this quadratic equation. So x is supposed to be equal to the opposite of b. Opposite of negative 13 is positive 13, plus or minus the square root of b squared. Well, the square of negative 13 is 169, minus 4 times the a coefficient, which is 6, times the c coefficient, which is negative 15. All of that divided by 2 times the a coefficient, which is 6. So we have x is equal to 13 plus or minus the square root of 169. And again, isn't the minus here going to make plus? Minus the minus is going to make plus. And oh, let's see, we've got 4 times 15, that would be 60, and 60 times 6 would be 360. All of that divided by 12. Better make sure I'm doing all this right here. I'll check out the calculator here just to be sure when we need to do a little more work. So x is equal to 13 plus or minus the square root of 9 and 0 is 9, 6 and 6 is 12, but on the 2 carry the 1, 3 and 1 and 4, 1 is 5, 529 divided by 12. Now, I have no idea whether 529 is one of my perfect square numbers or not. Remember, a perfect square number is a number that when you take the square root, you get a whole number answer. Since I'm not sure about that, one of the things that I often suggest you do is take your calculator and see what happens if you try to take the square root of the number. So take the square root of 529. Whoa, that was nice. 529 is actually a perfect square number. The square root of 529 is 23. So our expression now becomes x equals 13 plus or minus 23 divided by 12. When you can take the square root and get a whole number answer, remember when you take that square root, the square root sign then is gone. Now we can just finish out this arithmetic to find our 2 solutions. So one solution is x equals 13 plus 23 divided by 12. And the other solution is x equals 13 minus 23 divided by 12. See how that plus or minus produces the 2 separate solutions for us here? Well, 13 plus 23. Oh, what's that? That's, what, 36, isn't it? 20, 33, 33 is 36. So x equals 36 divided by 12, which is 3. So one of the solutions to that original equation is 3. And here we have 13 minus 23, that's negative 10. So x equals negative 10 twelfths. So x equals negative 5 sixths when I reduce that fraction. So the 2 solutions to that equation are 3 and negative 5 sixths. What this actually tells us, when we have what are called rational solutions, which is what these are. Rational solutions are solutions where you don't have the radical sign in the solution any longer. When you find that you have rational solutions, that tells you the original polynomial had been factorable. But if I'm not really that good at factoring, this method is probably better to use because this method always works, whether that polynomial is factorable or not. So probably it's a smart idea to learn a method that always works instead of trying to figure out if the polynomial's factorable. Just use the formula, and the more you practice it, the better you'll get at it, and you'll find that it's really not too difficult to use with a little bit of practice. So here again is another example of using the quadratic formula to solve this quadratic equation.